Okay, so today's lesson is called Graphing Logarithmic Functions, although we're going to be graphing both exponential and logarithmic functions. Just before we get started, you'll notice that today's lesson will look a little bit different. It's meant to be a bit interactive and have people come up on the board, but that's not going to happen on this video. So there's a couple of things you can do. One, you could actually go off and try and go through this as an interactive part of your learning if you wanted. The way you can do that is to go to Moodle. So I'm just going to demonstrate that here. We'll go to Moodle, and you'll notice that under our units here, Unit 4, this day we have the notes, Day 8. We have the answers and a blank version of these notes, but we also have the special one here, the notebook version of this. So if you wanted, you could download this right here. So you just go and save target as, and then put it someplace and download it. Then what you would need to do is go back to your home screen here, and at the very top up here you'll see there's a Smart Express. This is an online viewer of notebook lessons. You can click on that and it'll go right to this website, and this is a spot for you to open up notebook files. So if I actually go and open this up and you go to where you find it, I saved it right here, and go open, it allows you to actually go and do the interactive part of this site. So if you're watching the video in class right now, just you might want to do this later on if you want at home and just watch today's lesson. Or if you're watching this video at home on your own, you might be more interested in actually going and trying it out. So when you go off and it says do all this sort of stuff and then pull this across, and you can actually see what's going on. So this is an option. But for the video that I'm recording, I'm just going to go through and do it myself, and you can watch and see how it goes. So back to the lesson. I wouldn't stress about taking notes. You can just watch and get the idea of what's happening, and then there's a handout that you'll have a chance to actually try some on your own. So don't worry about copying this down. Just watch, and we're going to go forward. So as I said, we are going to graph logarithmic functions, but there's a big connection between logarithmic functions and exponential functions. So we're going to start by graphing an exponential function. And the graph we're going to look to sketch is this one here, y equals 2 to the power of x. So we're going to do it by a table of values, and we would have seen this last year in grade 11, but let's remind ourselves of what it looks like. So I'm going to start at 0 here. If it's 0, this would be y equals 2 to the power of 0, and 2 to the power of 0 is 1. If I did 1, so that last one would be 2 to the power of 0 is 1. This would be 2 to the power of 1, so of course that's 2. This would be 2 to the power of 2, so that's 4. What about this? 2 to the negative 1? Well, of course that means 1 over 2 to the 1, which is 1/2. And 2 to the negative 2, that means 1 over 2 squared, which is 1/4. So we've got our table of values, and we can graph it. So I'm going to start at 0 again, 0 and 1, 1 and 2, 2 and 4, a negative 1 and 1/2, and negative 2 and 1/4. And we understand the shape of the exponential graph is like this. And we go from there. If you remember some of the properties of exponential functions, you'll remember that all exponential functions will go through this point 0, 1, because it doesn't matter what the base is, anything to the power of 0 is going to be 1. So they all go through that point, regardless if it's 2 to the power of x or 3 to the power of x, all of them will go through that point. The other thing is the graph comes down and approaches but does not touch this imaginary line here. And that's an asymptote, because no matter how small these negative numbers get, negative 4, negative 6, negative 8, keep getting smaller, you're going to get smaller fractions, but you're never going to get 0. And if we wanted to verify this, we can just pull this graph. And you see the graph right there, overlap of mine, with your y-intercept at 0, 1. And so there it is, you see it at 0, 1. And your horizontal asymptote at y equals 0. So no surprise there. So that's how we draw y equals 2 to the x. If it was 3 to the x, the graph might be a little bit steeper. 4 to the x, even steeper. But what we're going to focus on is just 2 to the power of x and say that that's sort of our baseline one for all our exponential ones. So then if we go back and remind ourselves of what we did in the very first unit, we translated graphs. Like we took parabolas and shifted them left, right, up, down. We took new functions like the root functions and stretched it, flipped it, moved it left, right, up, and down. So we can do the exact same thing here with the exponential graph. So in this case, it says drag the red star to translate the graph. This one is 3 to the x. It works for 3 to the x, 2 to the x, doesn't matter. Drag it 2 units up and 1 unit to the right. So what would this graph look like? So let's actually try it. So we would go off and move this 2 units up. So there's 1, 2 units up, and 1 unit to the right. So I'll move it over here. And we get that graph. So that's been moved. Let's just before we pull over it is, let's see if we can check our graph to see if that's right. So there's the graph here, and you see the red one has been moved correctly. 2 units to the right, or 2 units up and 1 unit to the right. So there's the graph. So now it asks this question, what is the equation of this translated graph? Let's think about it. If it's moved 2 units up and 1 unit to the right, let's remember what we learned about translations before. If the number is inside the function, it moves left and right, and it's opposite to what you think. If it's outside the function, then it's just up or down. So let's think about inside the function. What does it mean to be inside this function? Well, inside the function we mean part of the exponent. So if it moves 1 unit to the right, then that part is going to be 3x minus 1. So that's inside the function, so opposite to what we think. You could even put it in brackets if you wanted. Think of it as inside the function. And it's opposite to what we think. So if we see x minus 1, then we know that it moves to the right one. And then how about this 2 units up? Units up. It's actually 2 units up. Well, then that would be outside the function, and it would be just a plus 2. So let's check and see if that's true. So we can pull here. There's the function is 3 bracket to the x minus 1 plus 2. It also talks about the y-intercept and the horizontal asymptotes. The y-intercept you see moved as well, but it's moved up in a little bit. But the one I'm really interested in, the horizontal asymptote. Let's think about what the original did. So if I drew an original horizontal asymptote, it would be right along here. Now, if the graph moves, then the horizontal asymptote's got to move as well. So how does this horizontal asymptote move? Oops. Well, the horizontal asymptote is going to go through the same steps. It's going to move 2 units up and 1 unit to the right. So of course, if I move it 2 units up, you'll see the horizontal asymptote has moved from x equals 0, or sorry, y equals 0 to y equals 2. And now I could move it to the right, except this line is infinite in both directions. So does it really matter if I move it right or left? No. All that we're interested in is how it moves up or down. So the horizontal asymptote is now at y equals 2. And that shouldn't be a surprise because my graph has moved up 2. So not only the graph moves, but the horizontal asymptote moves. So of course, we can move exponential functions. We can move them left, right, up, and down like we did in that one. Or we can flip them, right? We can reflect them and do all that sort of stuff. So if we look at this, how is the graph of f at x equals 2 to the power of x transformed to create the red graph? So if we take the blue graph, what happened to make the red graph? So if we click on the graph for a hint, we might be able to see it. So you see the blue graph, flips over to make the red graph. I can put it back. That is a reflection about the y-axis. That means it's a reflection left or right. How do I influence things left or right? Well, I need to look inside the function. And how do you do reflections? Well, you put negative signs. Remember, if there's a negative outside, it flips it down. But here we want to flip it left or right. And so we need a negative inside the function. What does it mean to be inside the function? We're going to look right in here. So the equation for the red graph is y equals 2 to the negative x. So the graph is reflected through the y-axis. The function for the red graph can be written as f at x equals 2 to the negative x. Now, why did the answers also say 1/2 to the x? Well, if you have 2 to the negative x, the negative in the exponent tells you to take the reciprocal of the base. So you could also write it as 1/2 to the x. And if we stop and think about it, this red graph looks like one of those decay graphs. You see how the numbers are getting half as big, half as big, half as big as you go down the graph. So the other way to write it is y equals 1/2 to the x. But when we're comparing it to our translations, I like to think of it this way, because you see the negative inside the function. Inside the function shifts, does things left and right, so it's going to flip it left or right. So again, if you're just watching this in the class, maybe you could pause and you could ask people to come up and actually try it, although it's not going to work on the screen. So I guess you'll just have to watch me push things. If you're trying this at home and you're doing the viewer, you can actually make some guesses. So what we're looking for is 2 to the x plus 1 minus 1. So if we think about it, we're going to read this and do all of our reflections and our translations. For starters, you see this as x plus 1. It's within the function, so it moves it left or right. And this one's going to move it left 1. This minus 1 is outside the function, so it's going to move it up or down, and that one will move it down 1. So what we're looking for is the regular y equals 2 to the x graph, which we just saw looks like this, except we got to figure out which one moves it left 1 and down 1. So we see we've got a spot here. Really, we're going to look for maybe the asymptote to help us move it up or down. This one here, it looks like the asymptote is way up here. So to me, that looks like this has been moved up 1. So I don't think it's that one. If I click on this, I'll get another option. Again, this one has an asymptote here. So that one would be moved up 1, and I don't want that. So I don't think it's either of these graphs. What about this one over here? Well, this looks like an option. You see the asymptote is down here. So this graph is down 1. The question is, has it also moved to the left? Well, to me, it looks like this point here has moved over to that. This looks like it's moved to the right. I want one that moves to the left, so I'm going to anticipate that it goes over here. Like this graph will be over here. So I don't think it's this one. If I click here, I should see another option. Now it looks more promising. You see the point, or there's the asymptote here. And this point probably came up from here where it's moved down and over. And so I think that's my answer. I can pull and check to see. And there's the one I anticipated. and it looks exactly like we had. So that's the correct answer. Again, the whole idea here is getting us to recognize that how we move exponential functions is exactly how we moved everything else. Inside the function moves left to right, outside the function moves up or down. And so finally, and this is really what I want you to do, and you could write this down if you wanted, let's actually do a practice sketch. So here we have y equals 2 to the x minus 3 plus 1. So looking at our notes, we know that this graph moves inside the function there, right 3, and that part up 1. So just like in all the other functions, I'd like you to do a preliminary curve. In this case, I'm going to start with my original. My original is y equals 2 to the x as my original exponential function. Goes back to the first slide that tells me it goes here, and then 1, 2, and 2, 4, and 1/2 and 1/4. And I'm going to lightly draw this. Lightly draw it with my pencil, so of course I'm going to cheat here. And you see there's the original. Now I have to move this one right 3 and up 1. The problem with moving it right and left is it's hard to lose. You lose track in a hurry where it goes. So you see as I'm moving, it's hard to figure out where is it. Did I move far enough left? Did I move up enough? I don't know. It's hard to figure out. So what I like to do is just take a spot on there and move it. This is a really good spot. So I'm going to move that one right 3 and up 1. So that one's going to move right 3. So there's 1, 2, 3, and up 1. So this one's been moved. If we move it to the right 3 and up 1, then we get our new point. So this point becomes here. And you can do it for all the points if you want. You know, this one can move over 1, 2, 3, and up 1, and that goes there. This point here can move 1, 2, 3, and up 1, and there's that point there. I'm just going to erase that so it's not in the way. But there's the point. And we have this sort of shape happening. The other thing that's really important is the asymptote's going to move too. So the asymptote's going to move here, from here, and it's going to move right, but that doesn't change anything. But if we move it up, it's going to move up to here. And now I can use that as a reference to draw the rest of my green curve. There we go. There's my graph. So there's the y equals 2 to the power of x minus 3 plus 1 that's been moved right 3 and up 1. I can check and see if my answer is right. So there's the graph. You see there's my red line there, and you see how it's virtually covered by the green line. There's the asymptote, or the vertical axis there, the asymptote. Guess my green line could be a little bit better if it was actually going through there. But there's my graph.